Hello everyone and welcome to this video on the Python programming language. So in this video I will attempt to analyze Dogecoin. Now for those of you who don't know anything about Dogecoin, well Dogecoin is a cryptocurrency invented by software engineers Billy Marcus and Jackson Palmer, who decided to create a payment system that is instant, fun, and free from traditional banking fees. And you may or may not know that it has been extremely popular lately, with its price literally rising 800% in less than a month. So before we begin, if you like the videos on this channel, then be sure to click that subscribe and like button, and to be notified about new videos from this channel, hit that bell notification. And I must say that the material in this video is purely educational and should not be taken as professional investment advice, as I'm no financial advisor, so invest at your own discretion. All right, so right now I'm on Google's website. It's called colab.research.google.com, and I'm on it because it makes it easy to start programming in Python. So all you have to do is go to this website and log in using your Google account and get started writing your Python code. So to get started writing this code, you're going to want to click on File and then click on New Notebook, where a new tab will open up for you, and then eventually a new cell will open up for you. Now in this cell, I'm going to write in a comment. I'm going to put in a description about the program. So this program analyzes Dogecoin. And this way I could just go back and read this description and know exactly what this program is about or what it's supposed to do. Okay, so let's go ahead and create a new cell. All right, now in this cell, I'm going to import the libraries that I plan on using throughout this program. Okay, so I'm going to import NumPy as NP, and next I'm going to import pandas as PD, and I'm going to import matplotlib.pyplot as PLT, and I'm going to give the plot a style. So I'm going to type plt.style.use, and I'm going to use the 538 style. And then I'm going to run this cell by clicking this button here to the left, and let's see if we have any errors. Okay, so no errors, everything looks good. I'm going to create a new cell, and now I'm going to load the data set that I plan on analyzing. So since I'm on Google's website, I'm going to use Google's library to do this. So from google.colab, I'm going to import files, and then I'm just going to type files.upload, and then run this, and this will allow me to upload a file. Looks like I actually have a issue here, and that's because I put file instead of files. So let's put an S here, and let's run this again, and now let's click choose files, and I'm going to upload this cryptodata.csv file. Okay, and now that is done, I'm going to create a new cell, and I'm going to store this data into a variable. So here we're going to store the data into a data frame. All right, so I'm going to create a variable called df, which is short for data frame. I'm going to set it equal to pd.read_csv, and I'm going to input the name of that file right here. So I'm just going to come up here and highlight it and copy it using Control C, and come down here and paste it using Control V, and just like that, we have stored the data. Okay, so let's go ahead and take a look at the data. So I'm going to type show the data and just type df here. So let's run this. Okay, and now we can see this data set. So it contains a date column, it contains a BTC column, which is Bitcoin, it contains an LTC column, which is Litecoin, a Doge column, which is Dogecoin, and a ETH column, which is Ethereum. All right, so I'm going to transform the data just a little bit. So I want to set the date as the index. So in order to do this, I'm just going to set df equal to df dot set underscore index, and I'm going to input pd dot date time index, and I need to give it the date column dot values. Okay, so that should do it. Let's go ahead and run this. All right, and now the indices have the date for the indice values. All right, and next I want to get rid of that date column. So here I'm going to drop or remove the date column. So in order to do this, I'm just going to set df equal to df.drop, and we're going to input the date column, and then I'm going to drop on access equal to, and let me just move this out the way. All right, so access equal to 1. And now let's go ahead and run this. And it looks like I actually messed up here because I forgot my square bracket right there. So let's go ahead and run this again. And there we go. All right. So now I have this nice data set. So we can see that this data set contains 1,872 rows of data and now just 4 columns, which are all cryptocurrencies. Okay. So let's go ahead and create a new cell. And now in this cell, I want to get some statistics on the data. So just type df.describe. All right, and let's run this. Okay, and now I can see for Dogecoin here that the maximum price for Dogecoin is around 7 cents or 0.078825 cents, or dollars actually, $0.078825. So it's about 7 cents. Really, we can almost round it up to 8 cents. And we can see that the maximum value for Ethereum is $1,901, and Bitcoin is $52,149, and Litecoin's maximum value in this data set is $358. Okay, so we can also see the minimum values in the data set. So we can see that Dogecoin didn't even reach 1 cent in this data set. So that's pretty crazy. And we can see that Ethereum was only about 90, I'm going to just round this up to 94. So it's about 94 cents. Okay, and let me go back up here to this data set. So we have, again, 1,872 rows of data. So that's a lot of, well, it's not really a lot of data, but it's still a decent amount to do some analysis on. All right, so let's go ahead and create a new cell. And next, I want to visualize and graph the cryptocurrency price, or cryptocurrencies price. All right, so in order to do this, I'm going to type my underscore crypto. So this will be a variable to hold my data frame. I'm going to set it equal to df. And I'm going to do this because I'm going to be changing that value for some other graphs that I plan on creating throughout this video. Okay, so next I'm going to give the plot a figure size. So just type plt.figure, and we're going to give the figure a figure size. Okay, so I'm going to set the figure size equal to 12.2 by 4.5. Okay, and then I'm going to loop through each column. So for C in my underscore crypto dot columns dot values, I'm going to plot each column. So I'm going to type plt dot plot, and I'm going to plot my underscore crypto at column C. Okay, and then I'm going to give the column a label. So the label will be the column name. All right, next I'm going to give the plot a title. So just type plt.title, and the title will be cryptocurrency graph, or maybe price. And next I'm going to give the x-axis a label. So type plt.x label. So the x-axis will contain the days. And next I'm going to give the y-axis a label. So type plt.y label. And I'm going to put crypto price with a nice little $sign. And maybe I'll put USD here. Okay, so that looks good. Next, let's give the plot a legend. So type plt.legend, and we're going to input the column values here. So my crypto dot columns dot values, and we're going to put it in the upper left location. So I'm going to set lock equal to upper left, and then I want to show this plot or chart. So I'm going to type plt.show, and let's go ahead and run this, and let's see if I have any errors. Wow. So got through this with no errors. So now we can see this nice little plot. We can see the price of the cryptocurrencies on the left, and we can see the days. We're looking at the years here, right? But in between there are days, so maybe I should put years instead. All right, so let's go ahead and run this again. All right, and again, the chart looks really good. So we can see that Bitcoin is much more pricier than the other cryptocurrencies, followed by Ethereum, which is right here. And then we can kind of see Litecoin just a little bit, and Dogecoin seems to be or seems to have the smallest price or the lowest price. All right, so it's really kind of hard to see the other three cryptocurrencies here because Bitcoin's price is so high. All right, well, let's go ahead and scale the data. So here I'm going to scale the data, and in order to do that, I'm going to use something called a min-max scalar, and the min-max scalar method scales the data set so that all the input features lie between two values inclusively. So I'm going to input a feature range, and I'm going to make that feature range 0 and 100. So let's go ahead and use pre-processing from sklearn. So from sklearn, I'm going to import pre-processing. Okay, and then I'm going to create a variable called min max underscore scalar, and I'm going to set this equal to pre-processing dot min oh, sorry there. So min max scalar. All right, and I'm going to give it a feature range like I said earlier. So the feature range will be between 0 and 100 inclusively. And then I'm going to create another variable called scaled, and I'm going to set it equal to min underscore max underscore scalar dot fit underscore transform our data frame, which is df. Okay, and then I want to show the data. So just type scaled and let's run this. All right, so now we can see that the data has been scaled. Let's go ahead and create a new cell, and I want to convert this scaled data to a data frame. So I'm gonna put that in comments here. Convert the scaled data into a data frame. So I'm gonna create another variable called df underscore scale, and I'm gonna set this equal to pd dot data frame. Okay, and I'm going to input scaled, and the columns will be equal to the same columns from our data frame. So that's df dot columns, and then I want to set the date as the index. All right, so I'm just going to type df underscore scale, and we'll set this equal to df underscore scale dot set underscore index, and we're going to input pd dot date time index, and then I'm going to input the index from our data frame. So just type df dot index, and then I want to show the data. So just type df underscore scale, and let's run this. Okay, so now we get this nice data frame of our scale data set. All right, so all of this was to basically create a visualization easily using this data frame. So let's go ahead and go back up to where we created this graph here, and I'm going to highlight all of this and copy it using Control C, and then come back down and paste it here using Control V. And now the reason why I have that my crypto variable is so I can easily change the data set. So now this will be df underscore scale, and let's see if everything else looks good. So I'm going to change this title to cryptocurrency scaled graph, and I'm going to change the y-axis to be the individual cryptos scale price from min to max. Okay, and I think that'll do it. So let's go ahead and run this. Okay, excellent. So now what are we looking at? Well, now we can see when each individual cryptocurrency reached its maximum price. So here, for example, we can see that Litecoin reached its maximum price a little bit before 2018. And it seems like the other three cryptocurrencies, that's Dogecoin and Ethereum and Bitcoin, all reached their maximum price a little after 2021. Okay, so it's pretty interesting. And we can kind of see um, some some correlation here. All right, so I think that looks good. Let's go ahead and create a new cell. And in this cell, I want to get the daily simple return. So the daily return measures the dollar change in a stock's price as a percentage of the previous day's closing price. And a positive return means that the stock has grown in value, while a negative return means it has lost some value. So let's create a variable called DSR, which will be short for daily simple return. And I'm going to set this equal to df.pct underscore change, and I'm going to input the value 1, although it automatically defaults to 1, but at least now I know I'm just looking 1 day back. And then I want to show the data, and I'm going to type DSR, and let's go ahead and run this. Okay, and so now I can see the daily simple returns. Okay, let's go ahead and take a look at it graphically or visually. So we're going to basically go back up here again. I'm going to highlight this. I'm going to copy using Control C, come back down here just to make this programming quicker. And I'm going to set the my crypto value to DSR. All right. So there we go. And I'm going to change the title to be daily simple return. Okay, and the y-axis will be the percentage change, or I just put percentage in decimal form. Okay, so everything else looks good. Let's go ahead and run this. All right, there we go. That looks really nice. So I'm going to change a little bit more on this graph actually. So we have the label. Let's give this an alpha. So I'm going to set the alpha equal to 0.7. And I want to make those lines a little bit smaller. So I'm going to set LW equal to 2, the line width, LW. So let's go ahead and run this. All right, so now it looks a little bit better. And what we can see instantly is that Dogecoin's percentage is pretty high here, right? So it has a very high positive return here. So we see that Dogecoin grew a lot in value around this time period. Okay, and we can see some other spikes as well, like here for Dogecoin, but this is definitely the most obvious and the biggest spike on this graph. All right, so pretty interesting. So let's go ahead and create a new cell. Now that we have our daily simple return, we can get the volatility. So here I'm going to print the cryptocurrencies volatility. Okay, so I'm just going to print the cryptocurrency volatility and put a colon there and just type dsr.std. All right, so all I'm doing is taking the standard deviation of the daily simple returns, and this will give me the volatility for each of these cryptocurrencies. And we can see that the most volatile cryptocurrency is indeed Dogecoin, okay? Followed by Ethereum, then Litecoin, and Bitcoin is actually more stable than all the rest of these coins from this data set, okay? So it's pretty cool. And volatility is very much so associated with risk, right? So the riskiest cryptocurrency seems to be Dogecoin. All right, so let's go ahead and create a new cell. And now I want to show the mean or the average daily simple return. So to do this, I could just type dsr.mean, and then I can run this. And now what we see here is we see that for Dogecoin, I can expect about a 0.6252% daily return on Dogecoin, which has the highest return out of all of the cryptocurrencies, followed by Ethereum. All right. So I think that looks good. Let's go ahead and create a new cell, and let's get the correlation matrix to determine if a change in one variable can result in a change in another variable. So here again, it's going to get the correlation matrix. So just type dsr.core, and it should be that simple. All right. And now we have this nice little correlation matrix. And what we can see is that Dogecoin seems to be, or seems to have low correlation with the rest of the coins, while Litecoin seems to have a moderate positive correlation with Bitcoin, and it also seems to have a moderate positive correlation with Ethereum. Okay, and Ethereum has a moderate positive correlation with both Bitcoin and Litecoin. And again, Litecoin has low um, correlation with the rest of the cryptocurrencies. All right, so that's pretty interesting. Let's go ahead and create a new cell. And now let's actually visualize this matrix. So, just to see it in a different type of graph. So I'm going to import Seaborn as SNS, and then I'm going to type plt.subplots. And I'm going to give my subplot a figure size. So I'm going to set fig size equal to 11 by 11. And I'm going to choose a heat map to visualize. And we're going to input the dsr.core. So we're going to put in that correlation matrix. And I'm going to give it some annotations. So I'm going to set annote equal to true. And I'm going to format it. So we'll set FMT equal to 0.2%. So let's go ahead and run this. All right, and now we get this nice chart, and we can easily see the moderate and the low correlations between these cryptocurrencies. All right, so it's basically the same matrix, just a little bit more pleasing to the eye. So let's go ahead and create a new cell. And now in this cell, I want to get and show the daily cumulative simple returns. Okay, so I'm gonna create a variable called DCSR for daily cumulative simple returns, and I'm gonna set this equal to DSR plus 1 dot comprod. All right, and I want to show the data. So I'm gonna just type DCSR, and let's run this. Okay, so there we go. Now let's go ahead and create a new cell now that we have this data. And of course, I want to visually show this data. So let's go back up to the graphs that we've created before and highlight them and copy using Control C and come back down. Actually, I'm going to go up and copy this one here. So I'm going to highlight all this, copy using Control C and come back down. And I'm going to paste it here using Control V. And I'm going to change my crypto to be DCSR. Okay. All right. And then I'm going to change the title to be daily cumulative simple return, and this Y value will be, or sorry, the Y label will have the growth of a $1 investment. Okay, and I think that'll do it. Let's go ahead and run this. Okay, and so now what we're looking at is we're looking at this nice cumulative daily cumulative simple return chart, and we can see that if we had invested $1 into Dogecoin back in 2016 and then sold it right around this time period in 2021, we would have had about $500. Of course, it dropped a little lower than that, so you still would have had above $250 had you sold here for Dogecoin. And we could see that our dollar wouldn't have went as far with Bitcoin and Litecoin. But what's interesting and surprising is that that dollar amount would have given us about $2,000 in 2021 had we sold it, um, had we bought and sold Ethereum. All right, so again, if we had invested $1 in Ethereum in 2016 and sold it in 2021, we would have $2,000 from that $1 investment. All right, so I think that's pretty interesting actually. So that's basically it. Thanks for watching the video, and a special thanks to the Patreon supporters on patreon.com, and a special thanks to Michael Gallagher. If you would like to become a supporter of this channel, I will leave a link in the description below. Also, if you would like to start investing yourself, then click the Webull link below and deposit $100 or more and get free stocks worth up to 1,600 USD. So thanks again for watching, and I hope you all have a great day. And if I made any mistakes in the analysis, please let me know in the comment section. I've tried my best here, and I hope to see you all in the next video.